Audio Jungle. Audio Jungle.
So here, this is nothing but 3D rotational flow. Okay. Now, if we'll talk about the 3D, then we should have all three axes here. This is nothing but X, this is Y, and this is Z. So what will be the angular velocity? The angular velocity here we have omega X, omega Y, here we have omega Z. So in this situation, what will be the angular velocity? Angular velocity omega is nothing but omega xi omega yj omega zk, right? So because you are writing 3D rotational flow in vector form, so it will be omega xi plus omega yj plus omega zk. Now if you write all the component here, then what will be the value, right? So as you know, this omega is equal to omega x, you know that value, and that value is nothing but, now directly I can write 1 by 2 in bracket omega x. So it will be omega dou y minus dou z dou w dou v. This is I. Omega x value I have written. Similarly, you will write omega y. What will be the omega y? So it is 1 by 2. It is u w. This is j. Similarly, we can write for the wz, omega z, it is nothing but this is the value of omega z, and this is k, right? Anyway, so what is the mean of this? Means when you will get this value. Now, if you check this equation, this complete equation on next page, I'll show you nicely. So it is omega 1 by 2, you can take common. What you will have 1 by 2, if you take common, then it is nothing but I plus in bracket dou z dou x u w j in bracket this is the value now. Okay, now when you will get this value, that also you have to focus. So if you check, if you write omega vector is equal to 1 by 2, if you use the matrix I, j and k, okay, I, j, k, and if you write this component here, what is that component? It's nothing but dou by dou x. It's nothing but dou by dou x dou by dou x dou y dou upon dou y dou z, and the velocity component u v w. If you solve this matrix, then what you will get? See what you will get. Again, I will write these values, it will be more clear to you. Bracket and see. First one, if you cut, then what you will get? It's a I in bracket, it's dou w dou y minus dou v dou z. Better I will write I here, or anywhere you can write plus. Second, take minus common. If you cut middle one, then it will be dou w by dou x, but you have taken common, so it will be dou u by dou z. Check this matrix determinants you solve, so you will get it. What is this? Dou u dou this dou z and dou w dou x plus k. What you will get, cut this, then it is nothing but dou v by dou x minus. What is the mean of it? The same value whatever you have here, the same value you are getting. See, same value you are getting after solving this matrix. Then what value you will get after solving the determinant? So what you are getting, the same whatever already you have, this the same value you are getting. Now if you see this, what is this actually? What is this? This is nothing but 1 by 2, and if you see this value, so this is nothing but curl of v vector. If I told you in short, I have written, if I told you find the v vector, you know v vector is nothing but ui vj plus wk. If I say solve curl v vector, this is called curl v vector. So what is the mean of curl v vector? What is the dou? This delta operator value is nothing but I dou by dou x j dou y, okay, plus k dou by dou z. What is the v vector that you know? It's nothing but ui vj plus w. So if I told you to solve the curl v, if you solve the curl v, so basically this is nothing but cross product of what? Cross product of I dou by dou x plus j dou by dou y plus k dou by dou z. Cross product of v is nothing but ui vj plus wk. If I told you to uh, solve this cross product, no? This is what cross product. So what will be the value? So this value is same, I j k, okay, dou by dou x dou by dou y dou y dou z u v w. This is the value of curl v vector. Huh? So always remember this curl v vector. If you I ask you to solve, so this delta, that is the operator. This delta can be anything. This can be scalar, this can be vector, because we are talking about the cross product, so obviously it should be a vector. So it is I dou by dou x plus j dou by dou y plus k dou by dou z. Now anyway, if this delta will be with scalar quantity, you will get scalar. If this delta will be with vector quantity, then you will get the vector result. Okay, anyway, so the point is, if you solve this curl v vector, this is very basic. Curl v vector, if you solve, then it's a cross product basically. Delta operator value I have given, I dou by dou x j dou by dou y plus k dou by dou z, and cross product of v vector. V vector is nothing but ui plus vj plus wk, that you know, right? If you see the cross product is nothing but this value. So same I have written here. And again, if you solve this cross product, this value, so the same, the big bracket, whatever you have, the same value you will get, this value you will get. So meaning is you can hold this bracket value, you can replace by curl B vector. Again, I told you, if you curl B vector means this, if you solve this, then again this value you will get, and if you solve, then this big bracket you will get. So the point is, what is the point now? Point is very clear. The angular velocity omega, what you have here, that angular velocity omega, what you have here, you also can write 1 by 2, okay, 1 by 2 in bracket 1 by 2, this is 1 by 2 here, and this uh, value is nothing but curl V vector, which is nothing but. So this is very special, okay, for single marks question they are asking for this particular point. huh? So what is the conclusion you got? Conclusion is very clear. The angular velocity is nothing but half of the curl V. Okay, half of the curl V vector. Always remember this. Angular velocity is nothing but 1 by 2 curl V vector, or you can write 1 by 2 curl V vector. This is very special. Or also you can say curl V vector, which is nothing but cross product of velocity vector V is equal to 2 times of the angular velocity. So the question they are asking, okay, based on this, so you just keep in bracket and just remember this. This is very special result what you have got here. This is very special result, okay. All right, this is very special result. This is the one now. Second, curl V vector, you got 2 times of angular velocity. They can ask for the flowing fluid, the curl of velocity vector V is equal to angular velocity is equal to 2 times of angular velocity is equal to 4 times of angular velocity. So it is equal to 2 times of the angular velocity, or simply they can give the angular velocity value and they can ask curl V vector. Okay, so means problem they can ask easily here. Okay, now, so angular velocity is done. This curl V vector meaning also you understood. Now we'll talk about the vorticity. Okay, so what is the vorticity? Vorticity, remember, it is denoted by xi. Okay, it is denoted by xi or zeta, you can say xi. It is denoted by xi. So vorticity in a fluid flow, you write it. This is also very important. Vorticity in a fluid motion, is taken numerically equal to twice the value of angular velocity. Angular velocity, or rotational velocity. Okay, now so what is the xi value? Xi is nothing but 2 times of the angular velocity. Okay, and you know that 2 times of angular velocity also is defined as curl V, which is nothing but curl V vector. Always remember this. Okay, this result is very important. This result is very important. You need to remember this. Okay. Now, like this xi value, when the component of rotation or vorticity are zero throughout the certain portion of fluid, the motion there is described as a irrotational motion. I'll explain about it. Let us finish first uh, the vector form of the vorticity as well as circulation also we have to talk today. So if I say what is the circulation, okay, what is the vorticity here? Vorticity in 3D. Vorticity in 3D flow. So again, vorticity is I plus J plus K, right? If you check, this is nothing but two times of the angular velocity. Okay, so two times of the angular velocity. So 2 into, if you check the angular velocity value here, 1 by 2, 1 by 2, any, suppose I'm interested to write chi x, so it will be omega x. What is the omega x here? See, omega x, omega x. So chi x will be omega x. So 2 into 1 by 2, omega x is nothing but y z d. So this value will be cancelled out 2 2. So it is nothing but dou w by dou y minus dou v. This value very important. Okay, I'll tell you the question in GATE they have asked, but how they have asked I will show you here. Okay, this equation is very useful, right? Similarly, we can write xi y also. It is nothing but 2 times of the angular velocity y. So 2 into 1 by 2. What is the y? It's dou z x u. 2 to cancel out. If you see, xi y is nothing but dou u by dou z dou w by. This is the chi y, which is nothing but vorticity about y-axis. Similarly, we want to calculate vorticity about z-axis. It is nothing but 2 w z. 2 into 1 by 2 in bracket x y v. Okay. Now, if you see, it is dou v by dou x dou u by dou y. Right. This is nothing but value of the vorticity. If you write the vorticity for the 3D now, so what will be the value here? See, what will be the value here? It is nothing but all together you can write. So it's nothing but for 3D chi x chi y plus chi z. Okay. This is for the 3D flow. This is the value of vorticity. How the question they are asking, I will tell you. Don't worry. Now, what is the point? Point is types of the flow, and that types of flow is nothing but two. Here basically we have started each and everything we have done for the rotational flow. We want to check the rotationality, then we had started angular velocity. Okay, so the point is for the rotational and irrotational flow, I told you, suppose we have a fluid here, and this fluid is what, suppose this is the fluid particle. Okay, this is the fluid particle here, and this fluid particle is what we are taking one axis, and if about the axis which is the center of mass, if about this axis the fluid particle is what rotating, if there is the angular velocity, then we can say this is what? Rotational flow. Okay. Actually this flow is what going on, this is continuous going on. Okay, this is the continuous going on. One part I have taken, and our point is what? If suppose this is the fluid element, if this is the fluid element, and about this is the suppose center which is perpendicular to the plane, if this is the center perpendicular to the plane, if there is the angular velocity, then what you have to say? You will say this is the rotational flow. This is the rotational flow. But suppose if it, rotational flow is there, it means omega value will be there, it will not be zero. But if suppose it is irrotational flow, if this is irrotational flow, then what is the mean of it? Meaning is very clear. The fluid is what flowing. The fluid is what flowing, something like this. The fluid is what flowing like this. But the particles are not rotating about their center of mass. The particles are not rotating about their center of mass. To take the element, to take the fluid element here, this fluid element, suppose you have taken like this. Okay, and for this fluid element you have checked. Now this is the fluid element, you just say it is nothing but A, B, C and D. The same element you have taken here. Fluid is what flowing, but if you check this particular elements and about the center of mass, that angular velocity omega is equal to 0, means it is not rotating. So it will be irrotational flow. It will be irrotational flow. Because if it is angular velocity is there, means all particles are rotating. Here I have taken one fluid element ABCD. If this fluid element ABCD we have omega does not is equal to 0, means omega is there, means it is rotating. Means it is rotating. Then it will be called a rotational flow. Then it will be called rotational flow. Last class only I had given the definition also. But what about irrotational flow? Once the particles, all particles are not rotating about their center of mass, then it will be irrotational flow. I say irrotational flow, it means what? If I say irrotational flow, that vector becomes 0. So if it is irrotational, means omega x 0, omega y 0, omega z 0. It doesn't mean omega x is 0, rest omega y and omega z is there. It's not like that. If it is irrotational flow, so definitely omega x, omega y, omega z, it is 0. At the same time, what about the curl v vector? If you see the curl v vector, it is nothing but 2 times of omega. Once irrotational flow is omega 0, so very important, curl v vector is 0. And apart from this all, one more important result apart from this all, what will be the xi x? Check the result. So xi x is nothing but it's dou w by dou y minus dou v dou z. Dou w by dou y minus dou v dou z. If it is irrotational, so this value will be 0. So automatically what you got? You got from this result, you got dou w by dou y dou v by dou z. Similarly, xi y. Okay, what is the xi y dou z dou x? This will also be 0. Means you got dou u dou z is equal to 0. At the same time, xi z also. V its u is 0. So you got dou b by dou x dou y. Okay, this is for which plane? Obviously, it will be for YZ plane. This is for which plane? This is for plane and all. Last class nicely I had explained. So hope you understood this. This is xi z. So obviously this will be on XY plane. Okay. So this is what I have written here. This is for irrotational flow. Okay, all points what I have written. This one, this one, curl v vector will be 0 once it is irrotational flow. That you need to remember. Angular velocity will be 0 when it is irrotational. And obviously xi x, xi y, xi z will be 0 for 3D. And very important, this one. So it depends. If they said on xy plane, then dou v by dou x is equal to dou u by dou y. If it is there, it means it is irrotational flow. This was asked in GATE. Okay. XY plane will be given to you and they say air rotational velocity. So what will be the correct answer? Dou v by dou x is equal to dou u by dou y. Huh? If option is given, if for irrotational flow on XY plane, dou w by dou y is equal to dou v by dou z, so obviously it will not be there because we are talking about XY plane. Dou u by dou z is equal to dou w by dou x. This is for XZ plane. So for XY plane, always remember dou v by dou x is equal to dou u by dou y for a rotational flow. Similarly, for XZ plane, dou u by dou z is equal to dou w by dou x, always for a rotational flow. So these are very important point. Okay, you need to remember. This is the one. Second, which is very important, if, okay, if curl v vector, this is also most of time this they are talking in XE gate or in GATE aerospace also. Curl v vector is equal to 0, curl v vector does not equal to 0. This is, if it is curl v vector is equal to 0, means angular velocity becomes 0. If it is there, then it is called irrotational flow. Okay, and then this will be called rotational flow. This is very important. For 1 marks, then easily they can ask question. Okay, in XE gate many times they had asked. Okay, always remember this. So these few points you need to remember. This is the one thing. The story is not end up here because we are talking about the rotational flow, irrotational flow. So why not we should finish vortex flow also at the same point, because after vortex flow we have to talk the circulation also, which is very important. Okay, which is very important. So here till now we have done for angular velocity, we have done for vorticity, we have done for the what that uh, after vorticity we have to do the circulation part here. So what is the circulation? Okay, so circulation, if we are going for the circulation, then definitely that vortex flow or vortex motion term will come into picture. Okay, vortex motion comes. So let us see what is the vortex motion first, then we'll talk about the circulation, then it will be more visible to you. Okay, so vortex flow, if so when all the particles, the same thing, or the streamline, okay, are rotating about one point, okay, rotating about one point or rotating about the center, okay, or it is concentric circle, okay, so such type of flow called a vortex flow. So vortex flow is basically a circulation, you can say. It's a circulation, it's a flow around a point called a vortex flow. Okay, so the flow particles or fluid particles are rotating about the a center or rotating about the fluid mass center, then it will be called as the vortex flow. Okay, so when fluid particles, when fluid particles rotate about fluid mass center, called vortex flow. Okay, so the same concept, just like angular velocity. Okay, just like angular velocity. So vortex, if you talk about the vortex flow, so we have a types of the vortex flow. Two types of vortex flow we have, basically force vortex and free vortex. Okay, force vortex and free vortex. So here one by one we have to discuss force vortex and a free vortex flow, because both are important at the same time, and we'll get mathematical relation also, and that is important. Okay, that is important. Mathematical relation is basically important. Okay, so hope you understood. So vortex flow or vortex motion is basically fluid motion when the flow revolves around an axis. Okay, when the flow revolves around the axis. Okay, which may be straight or curved, but the particles will be rotating about one axis, called vortex flow. Okay, called vortex flow. So now we'll talk first force vortex. Two types of vortex we have: force vortex and free vortex. Okay, so here you also, if you want, this is the one definition. One more you can add here, just for your information. The vortex flow is defined. It is defined as the flow of fluid, as the flow of fluid along 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 a curved path, path or 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 the flow of rotating mass of fluid, or the flow of rotating mass of fluid, rotating mass of fluid. Okay, now what is the mean of it? Simple. We can take the mass of fluid. See, this is the mass of fluid, and this is the mass of fluid, you can say here. And this mass of fluid, which is nothing but A, B, C, D. This is the fluid element, and this element will be containing a mass also, and it is rotating. It is rotating about point O, and it is rotating. So it will form a. It will follow a curve path also. Along the curve path, it will have motion, or you can say this is the center of mass. About this center of mass, this fluid flow will also be rotating. So something like, see, ABCD, this is the fluid element. Now this fluid element is what now rotating about point O. So this will be called as a vortex motion, or if fluid is what flowing in this way, so it will be called as a vortex flow. Okay, so if you the example of the vortex flow is basically basin, right? So suppose this is what basin, and if you see, this is the basin, you can say this is what basin here. Okay, we have fluid is what filled, and if you say this is the pipe, bottom side of the basin we have pipe, so all the fluid particle is what moving towards the hole, and nearby this hole, if you check this about this axis, the rotation of flow you will get. Okay, so there also you will get the vortex flow. We'll see it is force vortex or free vortex, but here also, or the best example, if you know cyclone and all in the sea, you might have heard. So that motion of the flow is what something like this. This is also the best example of the vortex. This is the vortex flow. All right, and the motion will be called as a vortex motion. So these are the example. And now we'll have to see about the force vortex and free vortex one by one. Okay, so now first we'll talk about the free vortex here. Free vortex here we'll have to talk. Two types of vortex we have. We can say free vortex and forced vortex. Okay. Now see, it's very simple, very simple. Obviously, if vertex is there, rotation is there. Okay, here this is the point, and about this point, the fluid is what rotating like this. Okay, this is what vertex. As I told you, in C it is cyclone best example, or somewhere in air also. Air also something like this. This type of tornado might you have seen. Tornado, no? It will be something like this. It will be something like this. This type of, which is called tornado. Hmm? In And if you see, all the air particles will be rotating, right? This is the tornado in air. In air you might have seen. And this type of cyclone, this is what cyclone in sea. This is what tornado. Huh? So these are the example of the vortex motion, or if talk, this is the vortex motion basically. And if during the flow it is happening, it will be the vortex flow, right? How to identify this? It's very simple. And another example also, if you have gone through the centrifugal pump or uh, turbine runner, so there also the rotation will be there because of the centrifugal pump. The impeller will be rotating. So because of the rotation, this type of flow will come into picture always. Okay, doesn't matter it is force or free, but this type of motion you will get. I mean, vortex motion you will get inside the centrifugal pump, inside the turbine, where the rotor is there. Like in centrifugal pump, rotor is what? Impeller. So impeller is what? Rotating. So fluid will also be rotating. So that fluid rotation will be called as a vortex motion, right? Now here first we'll talk uh, about the equation, main equation, like how to handle the vortex. uh, what is the governing equation of the vortex motion? So we can see governing equation of vortex motion or vortex flow. What is the governing equation? How to write this? See, it's very simple. We know very well torque. What is the torque? Torque is nothing but, it's nothing but force into perpendicular distance, which is r. Perpendicular distance. Force into perpendicular distance is nothing but r. Is nothing but torque. This is the formula of torque. Now how to relate with the fluid element? Because now we are talking about the motion, and this motion is what going to happen in the fluid. So how to get it? Simple. I can take the example of this fluid element. Suppose this fluid element here is circular, because it's a vortex motion, so obviously the fluid will be rotating about a point. So I'm just taking this fluid element A, B, C, D. This fluid element A, B, C, D I'm taking, and this fluid will be rotating with velocity V. Okay, and it is rotating about point O. So perpendicular distance will be R. Perpendicular distance will be R, right? Now obviously this fluid will have a mass M. Okay, so fluid mass is what? M, rotating velocity is nothing but v. If I say what is the angular momentum now, angular momentum of fluid here. So what is the angular momentum? It's nothing but mass into velocity. That angular momentum I am denoting by p. So it's nothing but mass into velocity, huh? Mass into velocity, right? Now, if I ask you what is the moment of momentum, so if I say moment of momentum, that means moment means what? You need to take the perpendicular distance also. So angular momentum you have written, it's a mass into velocity, but now if I say what is the moment of momentum, moment of momentum is nothing but what is the angular momentum into perpendicular distance, right? Angular momentum into perpendicular distance. What is the distance? R. R perpendicular. Now, like moment is what? It's a quantity into perpendicular distance. If I'm calculating force moment, then force into perpendicular distance will be the moment. If I'm calculating the moment of momentum, so momentum into perpendicular distance. What is the momentum here? Angular momentum, it is mass into velocity. So actually your moment of momentum is nothing but mass into velocity into perpendicular distance r. This is nothing but moment of momentum, which is capital M. I can write. So we got here capital M is nothing but what is the capital M? It is nothing but moment of momentum. Moment of momentum, right? So capital M is nothing but angular momentum into perpendicular distance. Now, if I ask what is the rate of change of angular momentum, you have to write this step. Rate of change of
सर आपका आवाज नहीं
सर
आ
आपका
रहा।
आवाज नहीं आ रहा।
so now my point is if you are writing rate of change of momentum, so rate of change of angular momentum or rate of change of moment of momentum, meaning is same. The rate means what? Per unit time, doesn't matter. Rate of work done, rate of flow of charges is current, rate of work done is nothing but power. So rate of change, that means you are talking about per unit time. Doesn't matter what is the quantity. Rate of meaning itself is per unit time. Per unit. Anyway, so here it's a dou by dou t of m. M is nothing but m v perpendicular distance. Now see, so you can take m mass is constant, r perpendicular distance is also constant. It's a dv by dt. What is dv by dt? Rate of change of velocity, you also know. Rate of change of velocity is nothing but acceleration. Rate of change of velocity is nothing but acceleration, right? And this mass into acceleration into perpendicular distance. What is the mass into acceleration? It is force. Force into perpendicular distance is nothing but torque. So what is the mean of it? This is nothing but rate of change of moment of momentum, or rate of change of angular momentum is nothing but torque. Now it's very clear. If fluid is what flowing, okay, if fluid is what flowing, then we have torque, okay, and once torque is there, so obviously it is means it is fluid is what rotating, it is existing now, because if it is rotating about a point, so torque will be there, there is no doubt about it, right? So automatically you got here torque T is equal to, what is the torque T? T is nothing but rate of change of angular momentum. It is proof now. How? You have started rate of change of angular momentum. Finally, you solve, then you got force into perpendicular distance, and force into perpendicular distance is nothing but torque. So you can write torque is equal to rate of change of angular momentum. That you need to remember. Okay, this also they can ask. They can ask about torque. So always remember. Finally, you got torque is nothing but rate of change of angular momentum, capital M, and this is nothing but dou by dou of MCR, perpendicular. This formula is very important because this is the governing equation of the vortex motion, but with the help of this equation we can identify force vortex and free vortex motion. Okay, if now if you talk about the free vortex, if you talk about the free vortex motion, free vortex motion, if I say free vortex, then what is the mean of it? See, suppose this is the vessel here, in the inside this vessel the fluid is what filled, simply fluid is what filled here. I just want to rotate this water about this axis. What I will do, I will start rotating this, so I will give the angular velocity, I will give the angular velocity to this fluid. Obviously once angular velocity is there, then it means obviously with the help of torque only angular velocity will come. This fan is rotating, your ceiling fan is rotating, means angular velocity is there. Once angular velocity is there, then definitely torque will be there. Without torque, how you will get angular velocity? You will not get. So if this fan is rotating, it means torque is there. If this fan is continuous rotating, means torque is continuous applying there. Continuous torque in terms of electric power, torque will be providing to the fan. Because of that, it is rotating, and that electric power will be converting into mechanical power, right? That is the whole concept. So similarly for the fluid also, if this fluid you want to give the angular velocity, it means you are having a torque. Torque is what providing. The best example, suppose in bucket, okay, you just put uh, your hand inside the water and just rotate your hand only. Once you rotate your hand, then water will be rotating about the center of the mass of fluid, means vertical axis. About that water will be rotating. Once water will be rotating, then water shape will be something like this, right? And this is the water shape now. Okay, so means torque is what applying here. And what is the torque now? Your hand is what rotating. So with with your hand only you are supplying the torque to the fluid. So because of that, fluid is what rotating inside the bucket. This is the practical example only. So means you are providing torque from your hand. Okay, so torque is what transmitting with your hand, and that torque is what transmitting to the fluid, and hence that fluid is what rotating. So till the moment your hand is what continuously rotating, water is what rotating. Immediately just pull back your hand from the water, then water is what is still rotating, but it will not be rotating continuously. It will rotate till certain moment, and then again water will get static condition. So 2 point here you observe. Once your hand is what inside the water and you are continuously rotating your hand and the water also rotating, that will be called a force vortex, because water is what rotating about one axis, means it becomes vortex motion. So 2 points you have observed. Number one, your hand is what inside the water and you are rotating your hand, so water is also rotating. So this will be called a force vortex. Okay, till the moment your hand is inside the water, called force vortex. But once you pull back your hand from the water, but water is still rotating for certain moment, that vortex will be called free vortex. Hope you understood. Two vortex I have told you, force vortex and free vortex. The best example is you have taken one bucket of water. Inside water, you just put your hand inside the water and rotate your hand. So if you are rotating your hand, water is what rotating, called force vortex. And after getting certain rotation, angular velocity you got, immediately you pull back your hand, still water is what continuously rotating, called free vortex. Now what is the difference? This is the practical example. Now you understood. Now if I ask what is the mathematical point of view, what is the difference between free vortex and force vortex, you have to say, for the force vortex, torque will be continuously supplying with your hand, hence it is force vortex. But you have, once you have taken back your hand outside from the water, so torque becomes zero now. But because of the initial torque what you had given, because of that torque only water is what rotating. But you are not supplying continuously torque, because hand you have taken back from the water. So once hand you have, because hand was the transmission for the torque. Your body is what supplying torque, just like a pulley and shaft. So pulley is what rotating, so torque will be, or power will be transmitting through the shaft. Your hand is what just like a shaft only. Okay, so once you have taken your hand outside, so there is no supply of torque now. So now torque becomes zero, but still water is what rotating about axis. Then only it will be vortex, right? So free vortex, force vortex. In force vortex, continuously torque will be supplying. In free vortex, torque becomes zero. Okay, hope you understood. So once for the free vortex, external torque becomes zero. Then what is the mean of it? Meaning is very simple. Just now you have seen the torque external. It was dou by dou t of mvr. This was the torque just now you had derived. No? This torque means this is the external torque base. Okay, external torque or simple torque only, no issue. So this torque becomes zero. So this dou by dou t mvr becomes zero. Ultimately, once you solve this, it will be constant because it's a derivative. Derivative becomes zero. Once you write mvr, it will be constant. Mass is what constant, so it will go to constant again. So vr is nothing but constant. What is the free vortex? Hope you understood. So in case of the free vortex, velocity v is what, you can say this is the constant now. So here you can say v is equal to c by r, where c is nothing but constant. So v is always, obviously it's a tangential velocity c, not a linear velocity. Here this is what tangential velocity or not, rotatory velocity, tangential velocity you can say, because it is rotating. So once rotation is there, then definitely tangential velocity will be there. So this velocity, whatever the tangential vr you got, vr is equal to constant. You can write v theta into r perpendicular is what constant. That from where you got, this is for free vortex. It's very important. They are asking question from here. Okay, free vortex. So now your v theta, which is nothing but tangential velocity v theta, it will be by r. Okay, r perpendicular or v theta inversely proportional to r. What is the r? R is nothing but radial distance. This is very special. V theta is tangential velocity. Velocity. R is nothing but radial distance. Okay, so now you got, if I draw the graph here for the free vertex, you will get here. This is nothing but v theta, and this is r. So it's inversely proportional. So for free vertex, plot will be what, v theta inversely the graph for the free vertex. Always remember, this is very important, very specific. All right.